Assalamualaikum warahmatullahi wabarakatuh. We are from Group 4 from FTUI. We will be presenting our research about quicksort, and this is our team.
My name is Gafrilatif, Aviandi Putra Adnanta.
And my name Muhamad Farhan Budiana.
And my name is Muhamad dan Satrio. First, I want to explain about quicksort. Quicksort is a data sorting algorithm that uses data splitting techniques into partition. So this method is also known as partition extend sort. And this is the illustration about quicksort. Quicksort algorithm. There are three parts to this quicksort algorithm, namely low, high, and pivot. Low is the lower limit or initial index of an array, while high is the end or last index of the array, and the pivot is the reference index. In a normal array that has not been broken down, the low value is 0 because the array starts from the 0th index. As for high, the value is array length minus 1. The quicksort algorithm is as follows. And this is the quicksort of algorithm.
Quicksort algorithm. In the quicksort algorithm, pivot selection is what determines whether the quicksort algorithm will give the best or the worst performance. Here are some ways to select the pivots. First, the pivot is the first element, the last element, or the middle element of the table. Second, the pivot is randomly selected from one of the table elements. Third, the pivot is the table's median element. And here's how quicksort works. First, find a pivot item in the array. This item is the basis for the comparison for a single round. Second, start a pointer, the left one, at the first item in the array. Third, start a pointer, the right one, at the last item in the array. Fourth, while the value at the left pointer in the array is less than the pivot value, move the left pointer to the right, and then add 1. And then continue until the value at the left pointer is greater than or equal to the pivot value. Fifth, while the value at the right pointer in the array is greater than the pivot value, move the right pointer to the left, subtract 1, and then continue until the value at the right pointer is less than or equal to the pivot value. 6. If the left pointer is less than or equal to the right pointer, then swap the values at this location in the array. 7. Move the left pointer to the right by 1 and the right pointer to the left by 1. And the last one, if the left pointer and the right pointer don't meet, go back to the step 1.
And next we have implementation of quicksort using Python. And here we have our code for the implementation of quicksort using Python. First, we define a function called quicksort, and it needs elements. And then we determine that length is equals to the length of elements. If the length is less or equals to that, or less or equal to 1, then we turn elements, else pivot is equals to elements.pop. In here, we determine the pivot for our quicksort. And elements.pop means that we are taking the last number from the list. Next, we create elements greater and elements lower list. And we start a for loop. For element in element, if element is greater than pivot, then we append it into elements greater. Else, if it's lower than the pivot, then we append it to elements lower. After that, we return quicksort of elements lower plus pivot plus quicksort and elements with elements greater to properly sort the elements lower and elements greater so they are properly sorted. And now We can get the output by just printing it out and placing the elements inside the quicksort function.
Oh, kamu jago banget.
Bebas patah-patah banget sebenarnya. And here is our output from our example. As you can see, it is properly sorted from low to high. So in conclusion, as we have previously mentioned, the efficiency of quicksort depends highly on the choice of pivot. It can make or break the algorithm's time and stack space complexity. However, despite all this, quicksort has a relatively low space usage and simple implementation, making it a very efficient and popular algorithm. And next we have our suggestions. In quicksort algorithms, pivot selection is the most important part of determining whether this quicksort algorithm can provide the best or worst performance. And that's all for our presentation. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.